Hello, my name is Ritesh, and my capstone activity project is Voice Command Classification System. The goal of this project is to take audio input and correctly classify them into predefined categories, such as different spoken words or commands. This project includes dataset creation and pre-processing, model training using deep learning, evaluation using accuracy and those metrics. First, I will explain how I create and prepare the dataset. The dataset consists of audio files belongs to a specific class or level. Inside inside these folders, there are multiple .wav files. Now talking about my code. So first of all, I install all the required libraries like librosa and soundfile. Then I import those libraries. So we used librosa for audio feature extraction, label encoder for to convert labels into number, and pair sequence to make equal length inputs. Keras layers like LSTM dense dropout for model building. On the next block, dataset. This variable stores the path where my dataset is located in Poland. And the next block is feature extraction. This is the one of the most important part of the project. I load audio using Librosa. I fix sample rate to 16,000 Hz and duration to 2 seconds. Then I extract MFCC feature. MFCC converts audio signal into numerical features so the model can understand sound patterns. Finally, I transpose the MFCC matrix to match the required shape. Then in next block, I load all audio files and prepare the dataset. I loop through each folder. For every audio file, extract MFCC feature, store features in X, and store label in Y. Also, I handle cases where dataset has nested folders. X stores input features and Y stores corresponding labels. And my samples in datasets are 120. I'm talking about next block. So next block is padding. Since audio files have a different lengths, so I use padding to make all inputs equal length. This is required because neural networks. This is required because neural networks need fixed input size. Talking about next block. So label encoder converts text label into numbers. Then I convert them into one hot encoding. This required for multi-class classification. Then next is model building. So I use LSTM. LSTM layer captures time-based pattern in audio, and the dropout used to prevent overfitting. And then use dense layer for then model can learn complex patterns easily. And the next is output layer, in which used softmax for classification. So softmax gives probability for each class. And then there are total parameters 29,092 and trainable parameters are 29,092 also. And then compilation. I compile the model using Adam optimizer, categorical cross entropy loss, accuracy as a evolution matrix. And talking about next cell, in this I evaluate model prediction using classification report. predict classes, compare with actual labels, and generate precision, recall, and F1 score. And then um, next block, I split the data set into training and validation sets using 80-20 ratio. Then I train the model where my where epoch is 25 and the batch size is 16 and validation data is used to check performance. The model learns pattern from audio during this step. And after that, I create a graph. This graph shows training accuracy and validation accuracy. If both increases, means model is good. If there is a more gap between them, that means model is overfitting. Then next block. So this block records real-time audio using microphone. It allows user to test the model with live voice. So we will try it. Stop. Then it will save as a test.wav. After real-time audio, after real-time audio recording, it will predict the command as a stop. We also manually do this. We can also try manually. First, I delete this, then upload test.wav file. Yes. First, we rename it. Yeah. So it will predict the command as a go. Since in our test.wav file, we have a go command.
Go.
So in this function, real-time prediction, extract MFCC feature, apply padding, pass to model, get predicted class. Finally, it prints the detected command. And then after that, in this cell, this shows the final training and validation accuracy of the model. My training accuracy of the model is 98% and the validation accuracy is 75%. This project successfully classifies voice commands using LSTM and MFCC features. It can be improved further by increasing dataset size, reducing noise, hyperparameters tuning. Thank you.